Hi, this is lead code question. Split the array to make coprime products. This is the third question of weekly contest 335. In this example, index equal 2, that because the product of numbers in the left side of 2, which are 4, 7 and 8, this equal 2, 2, 4, and the products on the right side of index 2 is equal to 2, 5. The GCD of these two numbers 2, 2, 4 and 2, 2, 5 equal 1, and this means that these are coprime, and this is the smallest index we return. So GCD is 1, so we return the index 2 because the products form a coprime. Now, how can we know if two numbers are coprime or the GCD of two numbers is 1? Let's take 14 and 7. We take or we get the prime factors for every numbers. For 14, 2 and 7. For 7, have 7. Now, if there is prime occurs on both numbers, here we have 7 and here we have 7, this means that these two numbers are not coprime because the GCD of these two numbers is not 1. So if you divide 14 by 7 is not, or 14 mod 7 is not 0, and 7 mod 7 is not 0. So the GCD is not 0. If you take another example, 14 and 5, prime factors of 14 are 2 and 7. For 5 it's 5, and as you can see there is no prime occurs in both sides, and that means these two numbers are coprime, and the GCD of 14 and 5 equal 1. Now, to solve the question, first of all we will return we will get the primes factors for all the numbers in the array, and we assign the count in dictionary called count. So the prime numbers of or prime factors of 4, 2 and 2, so we have two 2's, so count of 2 equal 2. Prime factors of 7 is 7, so count of 7 equal 1. Then we have 8. Prime factors of 8 are 2, 2, 2, so we have 3 2's. We add to this 3, so we have 2 plus 3, 5. Then for 15, prime factors 3 and 5, so count of 3 equal 1, count of 5 equal 1. For 3, primes is 3, so increase this by 1, become 2. For 5, primes is 5, so increase this by 1, so we have 2. This means that in the whole array we have 5 primes equal 2, 1 prime equals 7, 2 primes 3, 2 primes 5. Now we need to iterate over the array to check if the index, we can split it into two parts that can form a coprime. And to do that, we need to update the count to represent the right side in the map, and in the left side we have set represent prime numbers. So we start at index 0, we get prime factors of 4. Prime factors are 2 and 2, so we push to the set this 2 and 2. The set contains a unique number, and here we have 2 2's, so we subtract 2 from the 5, and here we have 3, and that means in the right side we have 3 primes 2. In the left side we have the prime 2 exist. So for every prime in the left side we need to check if it exists in the right side. So 2, how many, the count of 2 is 3, that means it's not 0, and this means that it's not at index 0, this is not coprime. Now we move to index 1, we have 7, coprime or the prime factor of 7 is 7, so we subtract from 7 1, this becomes 0, and we push this into the left side, so here we have 2 and 7. Now again, this 2 and 7 means there are primes on the left side that has the value 2 and 7. We need to check in the right side for every prime if they exist. So 2, the count of 2 is 3, that means there are 3 2's in the right side, and so this also is not coprime. Then we check for index 2. Index 2 we have 8, the primes for 8 are 2 and 2 and 2, so we subtract 3 from count of 2, so this becomes 0. We push this into the set, so the set remains as 2 and 7. We need to check for every prime if they exist in the right side. So 2, count of 2 is 0, count of 7 is 0, and that means all the prime in the left side does not exist in the right side, and so we return the index 2, and if not we will return -1 at the end.